This is session 2, part 4. Briefly look at drilling and fixing. So at the end of this part of the session, I want you all to be able to recognise various fixings used in the construction industry, describe where we would use these fixings, and explain why we would use different alloys like stainless steel and brass for particular tasks. Fixings, there's lots and lots of different types of fixings. A general description of a fixing device is something that's used to hold something in place, like screws and plasterboard fixings. Okay, briefly look at screws. Generally talk about screws using the term inches rather than the more modern millimetres and centimetres, though actually in screw fix these days they do generally sort of talk about 40mm and 50mm screws rather than sort of 1.5 and 2-inch screws. So yeah, the gauge tells us how wide it is between the threads. So that's showing the gauge there, and the length is that way, gauge is that way. Okay, so we might talk about using brass 1.5 tins to clip soil pipe. The 1.5 is referring to the length, whereas the 10 is referring to the gauge, the diameter between the threads. Okay, so we might use 5/8 of an inch H, which are kind of fairly thin for fixing, say for example 15mm saddle clips, light work basically, or 2-inch tins for fixing radiator brackets. And like I say, the 2-inch would refer to the length, and the 10 or the 8 in this case would refer to the gauge, the diameter of it. Might use even sort of longer and stronger screws if we're fitting a big heavy boiler. Okay, so a rule of thumb, you might need to make decisions about what sort of screws are right for the particular situation. They're made with different materials, or they might be coated with something to make them more resistant to corrosion. For example, a stainless steel screw will be quite resistant to corrosion, but so will zinc plated galvanized screws. They are quite resistant to corrosion until the galvanized coating sort of electrolytically corrodes essentially, and then they'll just start to rust. So you're better off, if you really want to do a long-term sort of job in a damp area, you're probably better off using a stainless steel screw or a brass screw rather than the galvanized ones. And don't use straight up steel screws because they'll just corrode almost straight away. Okay, so fixing devices, lots of different fixing devices. So brass wood screws, self-tapping screws, twin-threaded wood screws, countersunk screws, chipboard screws, mirror screws, plastic plugs like wall plugs, and plasterboard fixings and cavity fixings. Basically these are the same things, plasterboard fixings and cavity fixings, because plasterboards are used in cavity walls essentially. Okay, so the various screws available, this is referring to the shape, countersunk, and that's literally referring to that sort of the fact that it's kind of got a bit of a V shape underneath the head of the screw, which allows it to be driven into the wood, generally speaking. This is actually a slotted countersunk screw. This is a Phillips countersunk screw because it's still got that same sort of V shape under the head. Posi drive countersunk screw. This one's a mirror head screw, and you can sort of see that it's got a sort of decorative cap which you can screw onto the top to hide the screw head. Slotted countersunk screw. This is a raised head, a slotted raised head screw. Slotted is referring to this slot on the top here. Round head slotted screw, and a pan head slotted screw. We'll talk a little bit about each of these just now. Okay, so a slotted screw refers to the screwdriver slot on the head of the screw, like you can see just here. Phillips or crosshead again refers to the screwdriver slot. you can see this is just a straight up cross. Okay, posi drive, there's a very subtle difference. There's a couple of extra, well, 4 extra small grooves in there, which just help the screwdriver grip that little bit better to the screw head. So yeah, posi drive again refers to the screwdriver slot. So you can see the difference is these extra 4 little sort of small grooves there. Okay, countersunk refers to the shape of the head. You can have posi drive, Phillips or slotted countersunk screws like we've just seen. Countersunk screws are general purpose screws. They're used for most things, to be fair, like fixing bike clips, etc. You might want to be kind of a little bit careful if you've got, for example, saddle clips, the sort of copper ones. If you use countersunk screws, sometimes they can sort of bite into the clip and sort of start to chew them up. And you might want to use a round head screw, which we're going to look at in a second in those circumstances instead. Raised head and round head are pretty similar. The only difference between them is that the raised head has got a countersunk sort of shape underneath it, but it would still be raised above the surface of whatever it was screwed into. And the round head is flat underneath, so it would be useful to use with our saddle clips that you can see just here. Because if you use the countersunk shape one there, it would sort of, it could bite into that hole and start to kind of twist it out of shape. Okay, panhead screws. Panhead screws have got threads which go all the way up to the top. They're really good if you want to fix together metal sheets. Okay, quite often you might find panhead screws are also sort of self-tapping, which means that they'll sort of, you don't need to drill a pilot hole. You can just put the screw up against the metal and put the drill on, and it'll kind of bore its own sort of hole into the metal. Yeah, so they're handy bit of kit. So self-tapping screws or panhead screws would be both very useful if it came to fixing metal sheets. Okay. Don't use them all that often, but if you needed to clip into, say, for example, a metal stud partition, they're useful. They're really handy. Yeah. Okay. Mirror head screws. It's got the decorative cap, and you'd use them where you want the things to look pretty. Okay, here's a couple of examples here, and we might use them, for example, for fixing mirrors, obviously, but also possibly for fixing bath panels, cooker splashback, stuff like that, just for places where you want it to look nice. Okay. Roll bolts. Roll bolts are used where strength is required and can be used for hanging boilers, for example, or cast iron soil pipes. Basically anything where you really need a lot of strength, you'd be looking to use roll bolts. Coach bolts, again, heavy duty fixings. You quite often get coach bolts like the one on the right there, with basins. So you drill like a bigger hole and put in your wall plugs. So just screw them in, and it's fixed securely hard back to the wall. Excuse me. Plasterboard fixings, also known as cavity fixings. Some of them will just straight up be driven into the plasterboard itself. Some of them will go through the plasterboard and sort of spread out and grip onto onto the back of the plasterboard. And we'll look at a variety of these now. Okay, so spring toggle, this one here. I mean, any plasterboard fixing, you shouldn't use it to hold anything heavy. You know, it's not, plasterboard isn't very strong, so it will just get ripped out through the wall. So yeah, don't use plasterboard fixings for carrying anything with any particular weight. Okay, so the way you use a spring toggle is you'd sort of drill an appropriately sized hole. You'd squeeze together the two sides, push it in through the hole, and then make the fixing through whatever it is you want to fix to the wall. The spring in the spring toggle springs open, and that's that. Okay. Rubber nut fixings, pretty much pretty similar. The difference is that I would have a sort of a rubbery or plasticky sort of material with a metal nut at the end, and then as you screw the fixing in, it draws the nut back towards it, which squashes the rubber out into a sort of flange, which would then hold it into position at the back of the plasterboard. Cavity fixings are always called these wall anchors, or toggles, and you call them toggles as well. And they work on the same principle, except the difference is that they're a bit more permanent. As it's drawn back towards the wall, it sort of spreads out into sort of anchor shape, which would then stay in position. Drive-in fixings, we used to call them mole fixings. Another type of plasterboard fixing, but you should, again, these are possibly, in my opinion, some of the worst fixtures out there. Really fitting, really don't hold very much weight at all. Brass and stainless steel or alloy screws, kind of like I mentioned right at the start. What we want to do is we want to make sure that we use non-corrosive screws wherever it's going to be exposed to water. So the prime examples really are if you fit in soil pipe, especially outside, or rainwater pipe, backplate elbows for a hose union bib tap. Anything outside or in a bathroom, you should use brass screws or stainless steel screws. Okay. So yeah, internally, wherever they might be affected by moisture, you can see what happens if you don't. And yeah, and outside, like we said. So a bit of a few tips about drilling through tiles. It's not easy to get the grip initially, so a good tip is using a couple of strips of masking tape on the tile to give you that initial grip to bite into the tile. And there are also specialised tile bits available, like this one here. It looks a bit like an arrowhead, and this one here with a sort of diamond coating on the tip. Another quick tip: if you are going to drill into any walls, check it first with a cable tracer so you don't fry yourself. And now, briefly going to look at wall plugs. There's lots of different types of wall plugs, lots of different sizes. Make sure you use the right size for the drill the drill bit and the screw that you're using. Okay. The procedure is essentially you drill the wall with the correct size masonry bit, put in the correct size wall plug, and then put in the correct size screw. Jobs again. There's a chart here with a sort of guide on that there. Okay. Very, very briefly, going to look at nails, particularly copper nails, which you might, if you did ever use them, you'd probably be used for fixing lead. The reason that we do it is because they're very, very close in the electromotive series, and there's not going to be very much corrosion between them, which we'll talk about when we do the principles module. And screws, if you did use screws to fix lead, you should ideally use stainless steel screws. Okay. Now it's time for your task.